Hello. In this video, I'm going to go over Leetcode number 64, which is also called a minimum path sum. And the problem statement is that given an m times n grid filled with non-negative numbers, we want to find a path from the top left to bottom right, which minimizes the sum of all numbers along its path. And we can move either down or right at either point in time. So if we look at the example input, we have a grid, and to get from the top left to the bottom right with the minimum sum, we would need to take the path from 1 to 3 to 1 to 1 to 1. And the total sum would be 7, which would be our output. So this problem immediately seems to be a DP problem, mainly because of the minimum cost part. It seems that as we go through the grid, we can build off of smaller subproblems to get the final answer. So let's explore this idea. And let's begin by just considering the 0th column. And let's say we wanted to find the minimum cost to get from the top to the bottom. Well, it's obvious that at each point, we can add the cost of the current point and the cost to get to the point above it. So in this case, the cost to get to this point would be 1 plus 1, which would be 2. And then the cost to get to this third point would be 4 plus the cost to get to the second point, which is 2. So the total cost would be 6. So in this case, we're building off of previous costs, and we're constantly taking the cost to get to the point above. So now let's look at the elements on the 0th row. Let's say we wanted to find the minimum cost to get from the left to the right. So in this case, we would need to continuously add the cost to get the point on the left instead of the top. So to get to this point would be 3 plus 1, and to get to this point would be 1 plus the cost to get to this point, which is 4. So then the total cost would be 5. Now let's look at an element in the middle. So let's say we were looking at this 5. So now we have two options. We can take the cost of the element to the left or the top. And so in this case, it would make sense to take the minimum of these costs, because we want to find the overall minimum to get to the bottom right corner in this problem. So if you constantly take the minimum, then at the end we should get the minimum answer. So these observations basically give us an approach to solving this problem. So again, for the 0th column, we're constantly taking the element on top. For the 0th row, we're constantly taking the element on the left. And then for our middle element, we're taking the minimum of the element on top and element on left. Okay, so let's go over the code to this problem now. So the first thing we're going to do is we're going to create two variables to represent the number of rows and the number of columns in the grid. So int x is equal to grid.size, and then we know that if the grid size is 0, then we can immediately return 0. And int y, which is the number of columns, would just be grid of 0.size. And then we want to iterate through all of the elements, because again, we want to build off as we go through the elements. So let me write the code for that. And then again, while we're doing this, we know that if we're in the 0th column, which is when j is equal to 0 and I is greater than 0, then we want to constantly take the element on top. So then grid of I of j would be plus equals grid of I minus 1 of j. And then we know that if we're on the 0th row, so that would be when I is equal to 0 and j is greater than 0, then we want to take the element on the left. So in that case, that would be grid of I and then of j minus 1. And then the last thing is that we know that if we're taking a middle element, and this would be if I and j are greater than 0, then we want to take the minimum of the element on top and the element on the left. So that would be grid of I of j plus equals the minimum of grid of I minus 1 of j and grid of I j minus 1. And so at the end, we would just return grid of x minus 1 and y minus 1, which would be the bottom right element. And so let's try running this code to see if it works. And so we're getting that it's accepted, so let's try submitting it. And we get that it works. So thank you for watching, and if you enjoyed this video, don't forget to like, comment, and subscribe.